So today we're going to learn 3 properties. We'll learn more than 3. There's 3 that you actually have to memorize. The other ones are just kind of easy. You'll see what I'm talking about when we get there. But these are properties of equality and congruence. So here's the first one. It is the reflexive property. You don't have to write this. That's the title of our section. You already wrote it. But here is the reflexive property. Oh, you need me to go back? All right, so the important part is this. It's the reflexive property. And then you can actually just write, we'll just write these. This is kind of like a vocab word. Yes, the reflexive property. The reflexive property is just saying that something is equal to itself if it's the reflexive property of equality. I guess we can write congruence too. It doesn't take but a minute. Congruence, it's the same thing. Now they're just equal to, or not equal. They're congruent. So this should actually have a segment symbol on the top. So reflexive property, it's kind of like something's looking in the mirror at itself, right? Except that it's not flipped. It's not a mirror image of itself. It's just the exact same thing on one side of the equal sign as the other. Okay, something is equal to itself, or if we're talking about the actual segment or the actual angle, it's congruent to itself. The difference is here there's numbers, like the actual measure of angle A, you could replace with like 40 degrees and 40 degrees. Here we're just talking about the actual picture of angle A, and we know that they're congruent. So that's the difference between a congruent symbol and an equal sign. These things can be replaced with numbers. This is talking about the actual item from the diagram. But they're so similar. They're basically the same thing. It's just kind of a nitpicky difference. So if it's an equal sign, it's the property of equality. If it's a congruent symbol, it's the property of congruence. So this one I'll only make you write one. You don't have to write the congruence. But the symmetric property. So the symmetric property of equality has equal signs. Congruence has congruent symbols. You can write one or the other if congruence is something you like more. If you like a squiggle, you can write that one. But if we all write equality, we should be good. Basically, this is saying you have 2 things. Like if the first item is equal to the second item, you could reverse it and say the second one is equal to the third. That's the property of the symmetric property. So reflexive property is the exact same thing. Here it's 2 things that are equal and the order is just flip-flopped. Here's the third property we're going to talk about today. This is the transitive property. This one always reminds me of the law of syllogism where we would cut out the middleman, the repeater. That's the same idea here. So go ahead and just write one of them if you want to all write equality so our notes match. That would be fine. So again, you sort of see which part repeats and then you get rid of it. So they end up going straight from A, B to E, F. All right, so go ahead and just write number 1 and then write these 3 things. And we're going to match them. One of them is transitive, one of them is reflexive, one of them is symmetric. Yep. This is a YZ right here. And then its ST is congruent to a YZ. And if you're not sure what your options are, look back at the 3 things you just wrote down. There's one of each. All right, any idea which one's which? C is reflexive. There is only one item, and it is congruent to itself. Now, on your homework, you have to distinguish which one it is, either equality or congruence. So we can do that now just for practice. Is that an equal sign or a congruence symbol?
Congruent.
Congruent. So this would actually be the reflexive property of congruence. Good. All right. 2 more options, 2 more properties, and then we'll decide if it's congruent or equal.
B symmetric.
B is symmetric. How do you know? Yeah, there's only 2 things. And the order just flip-flops, okay? So this is the symmetric. Would it be equality or congruence?
Equality.
Good. And then part A.
Transitive.
That is the transitive, yes. And do you see how they just cut out the middleman? If segment ST is congruent to segment UV, and UV is also congruent to YZ, you can just cut out the UV and say that the first one and the third one are congruent. What are your questions? Almost. I got a few more things I need to show you. Okay, so this thing I actually just want you to watch. So you can put your pencils down. Just try to soak it all in. So this says in the diagram, N is the midpoint of MP. So N is the midpoint of NP, and that's a segment, so it should have a little symbol on the top. Okay, and P is the midpoint of NQ. Show that the length of the 2 segments is equal to one another. Okay, so in geometry class, there are these crazy things called proofs. Have you heard any of your friends complaining about proofs? No. Okay, so in geometry title and geometry, we don't do a ton of proofs. But geometry advanced, honors geometry, they do proofs like nonstop. So I just want to sort of introduce you to the idea of proofs. They appear on a few worksheets, but they're more of like a fill-in-the-blank process. But I do think it's important that you still see them. So this is just the first proof. I'm going to show you what it would look like, try to follow along, and then we'll practice on the homework. I think there's actually 2 on the homework tonight. We can do one of them together. So in a proof, there are always 2 columns. This column is the reason, this column is the statement. So like, what are we trying to show? This column is the reason. So like, how do you know that that's the case? So the first thing that always goes in this statement, is basically the directions. What did they tell us about? So they told us that N is the midpoint. Of MP. Now, I know that because it was given to me. I'm also given that P is the midpoint of NQ. Also given. Now, I am trying to basically form a list of reasonable facts and how I know them to conclude this right here. So I want to show that this guy is congruent to this guy over here. That's the whole point. So all I did so far was I just restated the things that I was given in the problem. Okay? What does it mean to be a midpoint? Why is this significant? Yeah, it's right in the middle. So these two segments are congruent. Good. And I'm actually going to change the problem a little bit. I'm just going to show that they're congruent. It's one extra step to show that they're equal. It's kind of nitpicky, so I'm going to just go show that they're congruent. Okay, so I know that MN is congruent to NP. Can you all agree with that? These two are congruent. How do I know that? What information did I use to conclude that these two are congruent? Yeah, the midpoint. So the reason we knew that is because we had a midpoint, and that's the definition of being a midpoint. So we will cite a lot of definitions and theorems that we know in our reasons column. So what do we know? How do we know it? All right, and we know that those are congruent because it's a midpoint. Now, the next thing we know, we have another midpoint. So this midpoint now shows me that what? If this is the middle, these are congruent, right? So same thing. Now I know that NP is congruent to PQ. Same reason. I'm just going to put ditto marks. Same reason. It's just the definition of being a midpoint. So they gave me a midpoint. I used it to show that two segments were congruent. They gave me another midpoint. I used it to show that two segments are congruent. Now, can I show that this one and this one are congruent? Yeah. What property is this? Of the ones we just learned, which one does that look like? So I can show that MN is congruent to PQ because of the transitive property. Good. That's your first proof. Now, I understand that proofs are super hard, basically because this is just so much information to come up with from such a short set of directions. You have to kind of know where you're going with it. That's why the proofs that you'll see in this class are a fill-in-the-blank proof. And we'll do one together, like I said on the homework. But I just wanted to show you one from-scratch proof, your first proof. How do you feel? Excited?
No.
You should. It's a big step. So I told you earlier, once the excitement of that proof wears off, we do have some business we got to take care of. And I don't think these are worth writing down. But they are worth noting because you will have to use them on your homework. These are properties of equality. We use these when we're solving equations. The property of equality says that adding the same number to each side of an equation gives you an equation that's true. So let's say I was solving an equation that said like x minus 2 equals 7. How would you solve this? X minus 2 equals 7. How would I find the x? Yeah, you just use the addition property of equality. That's why I don't think it's important to write these down, because you already know how to use them. You already know it's adding 2. Now I'm just telling you there's a fancy name for it, addition property. So it's basically saying if you add the same number to both sides of an equation, you can trust that the answer is true. Guess what? It works for subtracting too. If I had the same problem, but now I'm subtracting 2 to get x by itself, now I just use the subtraction property. So you can actually use all 4 of the basic operations when solving an equation. We do that all the time. Again, here are just the formal properties. So if you multiply both sides of an equation by the same non-zero number, you can't multiply both sides by 0, make everything 0. That's not fair. But any other number besides 0, if you multiply both sides of the equation by that number, the resulting equation is a valid equation. It is true. These are definitions. Yep. Well, properties, but yes, very similar. And then it also works for division. So if you're undoing multiplying by 3, you're going to divide both sides by 3, and that's a valid move. Mathematically speaking, you aren't doing anything wrong. The equation that you get is valid. It is true. It's called the division property. So it works for all 4 of the basic operations. The last one is the substitution property. The substitution property states that substituting a number for a variable in an equation produces an equivalent equation. So for example, if I tell you that x equals 3 and you take the x out and you put a 3 in, the equation should still work. The substitution property. So we'll actually just practice those last properties on the homework. We'll get that started together. But let's summarize first. So today, what do we learn? Properties. Good. Properties of equality and congruence. Great. All right, so sample test questions that you might see, I'll just actually give it to you. This is presented in a matching format, so sort of like what we do with vocab at the beginning of each quiz or test. The properties are a matching section on the end of your test. Okay?